Hi everyone, so I'm Grega Milčinski, I'm coming from Sinergise. Here I'm presenting the Copernicus Data Space Ecosystem, which is a European Space Agency and Copernicus initiative, but I'll also be sharing quite a lot of the opinions which are my own, right? Please be aware of that. That said, what I'd like to do is kind of present how I see where the Earth observation should actually lead us to, how to get there, and what is actually the role of the Copernicus Data Space Ecosystem, this big initiative and backed by the European Union in this process. So starting with what we want to do. So I'm kind of romantical about Earth observation data because I feel that it's the best source of the monitoring of our planet, right? It's systematic, it's objective. There's very few other data sources that would be as good as that. It doesn't care about country borders, it doesn't care about political system, it just tirelessly takes the data day in, day out, right? And as good or as bad the data are. By the way, what we are seeing here is a deforestation in the Amazon rainforest, the size about 10 times the Berlin area. So it's quite bad. Now, sometimes the images that the satellites are giving to us are really beautiful, sometimes are very horrible. What is important though, is that these are not just the random images. These are actual observations of our planet. These are values, right? And we should treat them as such. We should be able to understand what is on those images. I think this is super important in the world of the machine learning where you just get these results. And if you are not able to understand why they are as they are, then we have a challenge. Like an example, I asked ChatGPT to create me an image of the moderately flooded Berlin area by giving it the Google Maps input as an input. And what it came up, it is a moderately flooded something. And you see some elements of the Berlin, but I mean, we should be able, using getting the data, to determine how good these results are. I think this is the objective that we want to get. And now, having all this data and all this technology in place, the question is what we can do with it. The first thing, which I think we really should do, is make use of this in the enforcement of large policy initiatives. Such as in Europe, we have common agriculture policy, we have now the deforestation, the EODR, we have the greenhouse gases emissions. So all these things can be, to some extent, monitored with remote sensing data, and we should do that, right? That's the first step, which is kind of a low-hanging fruit to me. But where I see we want to really get to is to get this data into the everyday decisions. So I kind of see myself walking in a Zara store and looking at some T-shirt and thinking of what kind of an impact buying this T-shirt or the making of this T-shirt had to the environment. And I believe that Earth observation data can contribute to these results. However, to get there, we need to go beyond the world of the observations, reflectance values, even the NDVIs, right? We need to get the data in a form which is understood by the politicians and the managers. And this is Excel, right? They know how to use Excel. So we need to kind of convert data into the something that fits in the Excel spreadsheet. And I think we can do that by kind of creating the building blocks which are actually the values that fit there, like, I don't know, binary, yes, no, the times of the events, the crop type is a kind of this model. And we need to do it in a way that it actually works, right? Go beyond the prototype. It really needs to be used in operations in a continuous way. Otherwise, it just, it will not be used in practice. So, where are we on this path? Which is quite ambitious, I have to say, but I think we really have to get there. Now, one would say that the AI is developing so fast that it will solve all these problems by itself, right? Because it's really, really developing fast. But I kind of feel that that's maybe, if we just bet on that, we are then just betting on that one small piece of the puzzle there in the whole ecosystem, which is not sufficient. And we need to consider that Earth observation field is a niche field, right? I mean, most of the machine learning guys in OpenAI and in DeepMind, they haven't heard about remote sensing data yet because they don't care. They have so much other things to care for. And we need to kind of take and embrace the technology that was developed by others and fit it in this ecosystem. And we need to take care for all these other boxes, otherwise it simply will not work. So, where we are. First, the good things. I would double the opinion of Alex that there is enough of data, right? I mean, we have all these satellites, the open data, Sentinel, Landsat. You can do just about anything you want with the open data. If you need something specific, there is almost certainly a commercial mission that can provide you this data. So, I mean, obviously, there will be more needs and so on, but I think that we should stop focusing on creating more satellites, more missions to get yet more data, because what I'm really confident is that the data that we have so far are severely underused. Like, we really don't use, we are not even scratching the surface. And we should put the efforts into using what is already there. Now, the other thing which I think is good is that the data processing tools, I think, are also kind of a solved problem. We have several platforms and tools available which allow someone to prepare the data, that 90% that were mentioned, I think, by, I don't know, one of the previous speakers, the 90% of the value is in the preparation of data. You can do a lot of this with the tools that are already available, operational, and you just need to pick one of these and make use of it. And you can really do this at large scale. Now, the machine learning is also a good news because it brought so much of relevant tools to our field, and we really need to make use of it. And I mean, even the large language models, they have a place, like, because they will be able to expand the universe to the people who don't care about geospatial data, they don't understand geospatial data, but if we can make this interface that they just ask and get the image, that will really work good. And I mean, all the other tools that are being developed really are helpful in the process. However, sometimes these things are kind of perceived as too much of a easy thing to do, right? Because machine learning, you can put in the data and you get results out pretty quickly and it looks good. I mean, it really looks good. We have here an example on the left side of the Sentinel-2 data, and then on the right side, super resolved 1 meter Sentinel-2 data using the one of the, I think, guns or whatever. And it really looks good, and you are amazed how good this looks like. And you ask, why would you actually buy some data? Because you can just use free data and do that. However, the problem with the machine learning is that it's full of fake stuff, right? Hallucinations. And I think that with this specific model, we were able, because we do have real observations at high resolution data, we were able to find the real observations from the area that were used with the super resolved product and compare them. On the right side, you see the Pleiades is on the right side, which is 0.5 meter resolution, but the same range. But this is accurate data. And you see that some of the things that the super resolved product, just imagine there are not there, right? And some of the things are missing. And I think that's an important, I mean, obviously, every process has issues, has errors, have inaccuracies. The problem that we do is that we don't properly assess the results of the machine learning to see how accurate they are. People look at the data and say, it looks great, let's use that, right? But these data typically have some real consequences to someone, I mean, especially when we start using it in practice. And I think we should put an effort to understand the accuracy, and then we should do that. In this specific example, we did use this data on the use case of automatic field boundary delineation. And we did like a proper scientific assessment using the super resolved data, comparing it to a simple bicubic interpolation of the Sentinel-2. Result, no accuracy improvement whatsoever, right? I mean, for that specific use case, we demonstrated that super resolved model didn't really add any value whatsoever. And I think we should do this often as possible. And now, to do that, unfortunately, and I'm probably the old-fashioned guy, we need labels, right? We really need labels. Following this presentation, that was really good one, I was like, I'm comfortable being here. But I do believe we need labels. And I mean, probably the reason why I feel so is that in our company, we worked in the geospatial domain with the governments, and governments use this data in the real procedures which have monetary consequences to the people. And sometimes these things come to the court. And right, if you go to the court and you have nothing to show, then you have a problem. And I mean, maybe we don't need labels to train the models, I buy this, but we need the labels at least to be able to assess how good the models are. I think that's the minimum that we should do. And we lack the labels, right? I mean, we severely lack the labels. The funny thing is that in Europe at least, and in most of the developed world, we have a lot of labels because the remote sensing data is really picturing the real world. And we have a lot of registers of real world. We have the land cover cadastre, we have the building cadastre, we have road cadastre, we have the agricultural cadastre, we have all these cadastres that are like for, decades, tirelessly editing the data, which are not perfect, but of very good quality compared to anything that we get out of any kind of model, right? The problem is that this is scattered across the many organizations and almost never fits for the machine-to-machine use. And we need to put an effort to get there, right? And that's an example of a project by Technical University of Munich called Eurocrops, where they did exactly that, or they are doing it, right? They take the data from the European registers of agriculture and try to convert it into something that fits the machine learning models. And if you talk with them or you just observe this project, you see how difficult that is. I mean, they spent a ton of time. It's, I think, 3 years now in the process, and the data is still not as good as one would hope for. And that's a one-time exercise. What we need to do is make a way for systematically get this data out of those registers where they're updated, right? Because in 2 years' time, we'll need fresh data, and they will be there. We just need to get them here. Then another thing that I don't find very good is that we have lots of initiatives that are very similar or same, right? We have the land cover, global land cover done at least 4 times. Each of these projects for sure costed millions of dollars or euros, whatever. And I mean, they're all good, but for none of them we know really how good they are, right? I mean, here we actually do have some studies which are comparing that, which is good. But what I didn't see much is the use of this product. So in the applications, that people would actually take this and use it further. I'm not saying that it's not happening, but it's far from the investment that we put in. I feel that we should really stop just doing, reinventing the same wheel over and over again, and which we need to build on what other people have built that look legit. We should test it thoroughly, and then we should make use of it. But we always rather go into building yet another new version of something. And then this one is a bit Europe-specific, the cloud infrastructure. I mean, cloud infrastructure in Europe, it seems to be designed to address the use cases that people use it in Europe, and that's mostly storing the documents and running the business applications, which unfortunately doesn't overlap well with the complexities of the remote sensing machine learning. So I'm not saying that we don't have any clouds, right? We do have clouds, and we have cloud capacities, and people are building their own private cloud, but I think that we don't have them at the level to compete with the, let's say the hyperscalers that are out there. And we should put effort on that, and the best way to put effort on that is to use it, right? And integrate with it, and then complain and ask for better services and whatnot. Now, the last but not least, the thing that I'm really missing is that there are so many people that are working in research, but very few people that are willing to do the grind to put the research result into the practice. So we have a ton of prototypes, but very few that result in actual application. And I kind of feel that this is global, right? It's not just European, but most of the research projects end up with a prototype that is never used then, right? And I mean, it's a waste of effort because, and obviously there is a lot of work needed to do that requires to be done to make it to the operational product, but we need to do that. Otherwise, I mean, we'll never come to the end. So, where does the Copernicus data space ecosystem fits in this, in all this mess, right? First of all, it's a nice example of an operational project. So here, ESA, or the European Commission, contracted a system that should really work, and it's mandated by the KPIs. It's far from perfect, to be clear, right? I'm the first one to say so, but it's an operational product. You can go there and you can log in or register with your email and start using it immediately. And I think that is this is the way to go. It is, I'm quite confident, the largest archive of the Copernicus data in the world, currently exceeding 64 petabytes, planned to grow to 100 petabytes in a few years. It's there for a long time, at least by end of 2028 and possibly by 2032 if people are really happy with it and are using it, right? So there is this extension already in the contract there. And it was designed to be an open ecosystem, meaning that you can either go to the CDSC and just do all the work that you want to do there, or you can use parts of it, APIs or the data or whatnot, in your own system wherever you are and integrate with it. And it's there by design like that. And if you do something, you can, and I would ask you to do that, you can put it back to the CDSC in form of a data or in form of a application to actually share with others as well. Very important, I think, property of the CDSC is that it has all the Sentinel data, at least all the relevant Sentinel data are available online. And by, I really mean all, like full global archives of the data. The only thing that's an exception are like engineering and auxiliary products that probably only, I don't know, 0.1% of people have ever used at all. So you really can get all this data immediately. In addition to Sentinel, there's also the VHR dataset coming in, and we are building the cloudless mosaics to make it easier to work with the data, and so on and so on. Not everything is there, but you have an option to bring your own data there. Pretty simple, you just create a cloud optimized GeoTIFF or ZAR, put it to the object storage, and then there is a self-serve facility where you can register the data in the system, and then either use it yourself or share with others. I don't know, if you want to bring additional commercial satellite data into it, you can do that, or labels, or if you want to share the results of your work, which are often the geospatial data as well, you can do all of this directly. There are plenty of services and APIs. I'll not go into all the details because it would take much more than 30 or 45 minutes that I have. What is important is that all of these services are available free to use. Free, meaning that they are paid by European Union, to be clear, right? So most of us in this room are paying for this service to be operational. Our colleagues from abroad are kindly using it, and that's fine, because it is designed to benefit the community. Now, what is important is that because it's free to use, and to ensure that it's actually, that there is a fair distribution of resources, it has limited quotas. And sometimes it may happen that if you use it as a general user, you will bump into the wall. How it is designed is that if this happens, there are ways to get additional quotas by either using some of the research sponsoring options, or if you want there, you can even pay for the services to one of the commercial providers. So the idea is that you are not like kind of locked out as soon as you reach the quota, but there are ways to exceed your processing further on. Now, I want to just give a brief sneak preview in what the CDSC is. I'll be using the Copernicus browser, which is another operational tool that you can Google and just start using it immediately. For the sake because it's nice to demonstrate, but you need to understand that everything that you see is powered by the same set of APIs that are available to anyone to use, right? So you should use it. You should look at it not from, it looks nice, but how I could use these features in my own process. Let's imagine the typical remote sensing data science use case, agriculture monitoring. So if you're a data scientist, first you typically just want to understand the data, so you can go over the area that you're familiar with, zoom to the full resolution, and then as it is related to the vegetation, you would be interested in the time series, and the best way to just get to know it is to create a time lapse. In a few seconds, you can just explore and see how the data is changing and see what is the noise, kind of get familiar with it, right? And because this is the agriculture, you would be interested more in the vegetation indices rather than the true color, and you can do the same with the vegetation indices very easily. Now, when you want to start actually using this data, you'd want to extract the data out of it, and I'll do here what was previously said that we really shouldn't do is remove the spatial context, right? So what I did is that I outline the area of interest, and then I retrieve the statistical values of the, in this case, NDVI over a period of a year with some metadata so that you can remove the clouds. And now I fully agree that this is worthwhile exercise unless you really have the need for spatial context, because when you do that, you reduce your model by orders of magnitude, and that means you have all the next follow-up steps orders of magnitude faster, cheaper, and you can elaborate much faster. And it works as good as if you work with the pixels, again, for most of the cases, not for all. Now, so here we see the the typical pattern of a crop growing over the spring and then harvest and then some catch crop being planted there. And you can get this data like in a matter of seconds from the system for any place in the world. Whatever, if you want to get pixels, you can have an API for that. If you want to get the statistical information, you get that. If you want images, fine, it's there as well. Now, if you want to go larger scale, there are tools for that as well. Typically, what you would do is you would split the area into smaller chunks so that your machine learning process can handle them, and then you would take the data out of the system. In a typical area, you would get, let's say, between 70 and 150 observations per year. Many of these will be noisy. You can configure it to remove the clouds and do some gap filling. Again, up to you how to do that. And then in order to get kind of a harmonized cube, you would say, I would like to get 10 daily cloudless cube for the area from, I don't know, March to October. And you can configure this and then have it running over the area in the world. And in a few hours, you will have the data there, which you can then, I don't know, put in PyTorch or whatnot and process it further. If you want to do this on the smaller chunks, let's say the agriculture parcels, you do the same. You configure the process. You put the geo package with hundreds of thousands of polygons, and you have it running, and you'll have in a few hours the GeoJSONs that will be there. All self-serve, right? You don't need to communicate with anyone. You just use the APIs. Now, as this is remote sensing, we have a lot of existing knowledge, which is there in forms of the various indices, which you can make use of. This is an example of a bare soil index, which you can put in the script, and you get the results immediately out of it, which again you can use in your procedures to fetch the data over a specific area of time. You can develop your own algorithms. That's an example of an NDVI anomaly where you will see whether the NDVI is growing or falling, and you can take this. And you can very quickly tweak these algorithms and see the results and then iterate further on. Now, if you want to develop more complicated procedures, there is an OpenIO environment for that, both in the user interface as well as in the API. So you can make use of it. There are Jupyter Lab environments where you can just do this directly on the platform, or you can use the infrastructure as a service to use the APIs with all the other stuff that you want to do yourself. When you develop a model, you can then convert this model into, again, the processing graph, and then use this in your APIs. That's an example of a build-up area detection trained with the deep learning, and then converted into the script. And now we can see how it's running. And then, I mean, once you have it running, you can go immediately in Kenya and see how it's running there. Probably not good because you haven't trained it there, but at least you can get this feeling immediately and feedback, and you can iterate. And when you bump into the problem, there is a service desk which will help you. There's even a public forum which I would highly recommend to use, because if you do it publicly, then you're putting more pressure on the contractors to do it right? I feel that the Copernicus data space ecosystem has all the tools needed to really do the process from the prototyping to the evolution. So typically you start in the Jupyter Lab and you do some tweaking, and you use the synchronous API to get immediate a response to see how it's working, and you can try it in several areas by just changing the AOI. And then when you're kind of okay, you say, now I'd like to run this on the large scale, but I would still like to run it cheaply and fast. So what you can do smart is to reduce the scale, right? So you don't run it at 10 meter, but at 200 meter resolution, and you will still get results very fast, and you will see where things are strange, and then you go back and iterate and whatnot. And then when you're happy and you are confident with the results, you set it running on the full resolution. It will take a few hours, it will take thousands or 10,000s of euros, depending how complicated and large your process is. But then you'll have the results which can be stored on the CDSC and the APIs used to stream in the applications. So, it's not yet the done word, right? As mentioned in the beginning, what we need to do is to ensure, first thing that we need to do is to ensure that these data and technologies are used in the policy enforcement procedures. And luckily, in Europe, we actually do have a working example of that, and it's called Area Monitoring System, there to enforce the Common Agriculture Policy. And it's like a really nice example of how you have the data converted into signals that are specific to this use case, and then in that context, they call it markers. You might call it insights or planetary variables or whatever. In this case, they are, I don't know, crop type, when the mowing happened, when the harvest happened, all these kind of things. These are extracted from the remote sensing data, and then you have the step where you combine this into some decision-making process, which is just plain business rules, right, in Excel, as you would like, and then you present it to the final users, which in this case are farmers. And these systems are operational in Europe, in most of the member states, implemented by several parties, so we see that it can be done, and it really works well, and I kind of feel that this is the largest EO-based operational system that exists, right? Because it's really used, and it's used to the level that people are not getting paid for it, or they get penalties for that. Now, there are still some steps that we need to do. First, if you are research and industry, right, don't reinvent the wheel. Use the existing blocks and build the blocks that others will be able to use. We really need to do that. Then we do need to put more effort into getting the improvements of the labels, tapping into the registers that are already available. This is a long, tedious, and grinding process, and probably will need some public funding for that, because it's like for common good, and I would hope that this really happens. And you use the European cloud infrastructure. It might not be always the most convenient option. Sometimes it might not even be the cheapest option, right? And this is why, again, we'll probably need some public funding. But if we don't use it, then it will never get where it needs to be. If you are building your own infrastructure, it should at least integrate with it properly. Like use the CDSC data archive using the APIs and integrate with it so that we have these links established. And use, obviously, the Copernicus data space ecosystem as much as you can, because it's there for you. If you're an institution, first, I would say, instead of funding yet another building of a new system, try to use the services that are already available, because there are some available, and when you use the services that are available, you will be pushing these operational aspects, right? Act as an Anchor client. The CDSC is a nice example where ESA is acting as an Anchor client to the parties who have operational systems. The more that we have this, the more the service providers will push into actually making the services that really work, not that they're just prototypes. And when you have the open data by law, make sure that these really are open, because it still happens too often that they are not, right? And you should use Copernicus data space ecosystem because it was built by European institution for the European institution, so you should make use of it. And to be clear, it's not just for you, right? It's also for us. I mean, we as a consortium, we need to put effort into improving the performance and scalability. I mean, it's working, but it always can be better. We will be adding new data collection so that you can do more and more of this kind of research on it. And we need to ensure that the technology that we have is not like at the stage now, but rather that it evolves as the technology is evolving. And we also should be using the CDSC, to be clear. So I conclude here. Thank you very much. And if you have questions, I'm available.
Wonderful talk, and I'm sure we have plenty of questions. I see one in the very back, so if we could get a mic, very back.
Hi, Grega. This is Miriam Gonzalez from Up42 and Yo Chicas. So the question here is, I see one of the slides, and it says the funding is coming from the European Union. So Sinergise is a company from Europe, but then was acquired last year by Planet, a company from the US. So what is the concern in the medium and long term about the funding coming from the European Union?
I mean, that's a political question. I don't see, I'm a bit biased, right, to be clear, so take this answer as you would see it fit. I don't see there is much of a concern. Sinergise is a company from Slovenia. We are proud to be in Slovenia. If you have been in Slovenia ever, you know that we'll stay there because it's a really beautiful place to be. We are Europeans and we are proud to be there, right? And so therefore the knowledge, the operations, the service is all done in Europe. By the way, this was guaranteed by design. The ESA and Commission did really put a lot of effort into ensuring that this happens. So all the knowledge is happening here. Yeah, you're right, the Planet Labs, the international company, is owning Sinergise, but they are not involved in this process whatsoever. So they will benefit from it, same as everyone else is benefiting, but a part of that, they don't have any benefits.
Thank you.
Do you have any other questions? So while people are thinking about questions, I have one regarding extensibility. So if we follow your train of thought and think about all those prototypes, so how would a PhD student now integrate the own new prototype back into this ecosystem to make it usable for people, while you ensure, or we all have to ensure quality, that whatever ends up in there is actually correct and usable?
That's a good question. The answer is it depends a bit on how the prototype is designed. First of all, let's assume that the prototype works, right? So this is what still is remaining with the student, that the system cannot guarantee it. Then, the best way to do it, if you would design your prototype using the OpenEO paradigm, which is also strongly pushed by ESA and the Commission, then you can publish this in it's called the Marketplace Plaza. It's not probably the best term, but again, it's there. And then you can put these procedures to anyone else to use, and they start using it. If it's more complicated, if it is a Docker container, then you use one of the infrastructure resources, infrastructure services. You put the Docker there, and then you share it with others so that they can take this Docker as well. If it's an algorithm, you just put it again in the common environment. So generally, the difficult part here is to get the prototype to really work, right? And again, this is the tedious work that no system can help with. But once you have the prototype there, you can very easily deploy it and make it useful. There is a special part there called ecosystem services, which are designed to promote this kind of contributions. This is vetted by ESA, so they would get, whoever did it would fill a small form, and then ESA would look at it just to see that this is in line with the overall policies, and then we would put it there for anyone to use.
Awesome, very good. Do we have more questions? We have one over here. And we organize a mic.
Thank you, Grega. I was thinking, this morning we heard about the importance of trust for scientists to use data, right? That it takes, and it might take a year for people to build trust in a data set before they build, run science on it. I'm thinking the data we know, but it's also always, to me, I've experienced always a question, who hosts the data? What did they do to the data? How does the APIs I pull the data through, or the interfaces, do they transform the data? I would be wondering, have you encountered resistance from people to use these interfaces that now CDSE is preparing, but also Sinergise has been promoting with Sentinel Hub for a long time, because they think, it looks great, it works, but I don't know if I can trust it. Do you ever experience that? Yeah,
once or twice.
Oh, wow.
No, so it's relevant. First of all, again, you need to take into account that this still is an official service by the European Union, right? So they govern it. And in terms of the data not being changed, they really put a lot of focus to that. The data is stored on the object storage in 2 locations, one in Warsaw and one in Netherlands, on the Cloudflare clouds and the Open Telecom clouds, and it's available in the raw form, right? It unzipped, but unchanged. For Sentinel-1, we actually did a change. We converted it into cloud-optimized GTFs because we believe that this doesn't change the values, yet it contributes significantly to the cloud-native processes. But even there, in parallel, we have a raw format as well, because CISA cares so much about having the raw data. So if you want to use the data as they are, you can go to the object storage, take whatever pieces of data you need, and it's there in really unchanged way, because there are procedures ensuring that this is so, and you need to trust CISA in this case, not so much the contractors. In terms of the APIs, if you're using OpenIO, that is built, it's an open source product built mostly by Vito, but also by the community. So you can look what OpenIO is doing it, and then you'll get the trust from there. If you're using the Sentinel Hub APIs, this is a proprietary product, so you don't have this insight. What you can do is run some tests and see what you get out of it and compare it to the real data. And we did, I imagine 50 questions like this over the last few years. And we were able to demonstrate that the questions were always why it looks different. And then the result is always because you didn't take into account the complexity of the context, like you didn't use exactly the same coordinate system, you didn't align your area of interest with the area of interest of the data product. And if you show it them and then they get the same level of pixels out of it, then they trust it. And then, the more you go and the more you use more, more and more derivative products, the more you need to trust. And in this case, I guess you need to trust Sinergise or Vito or whomever built that product, that they did a good job and that there were so many people using it beforehand. But again, if you want to build everything from scratch, then you'll not come far, right? So you will need to trust the community one way or another.